Hello, this is STEM with Sid. Today I'll be going over topic 1.5, infinite limits. So infinite limits are fairly simple. It's just limits that go off to infinity. This could be infinity, negative infinity. So if I were to give an example, let me just show a small graph here. Here, I'll draw it better. A minute. Oh, it's not letting me. Okay, give me a second. Sorry, my drawing's pretty terrible. But anyway, this will go up and this will go up, right? Sorry. Now, what is the limit? Let's say this point is 2. We can say that the limit of this function as x approaches, this is f of x, so we'll say limit of f of x as x approaches 2. We can call that infinity, right? Because the left side's going to infinity, right side's going to infinity. So we can say that this is equal to infinity, right? Now, if I have another example right below this graph, let's say, looks like this with the vertical. This is called vertical asymptote when you get an undefined here, right? Like the 1 over x example I showed in the last video. The vertical asymptote is at x equals 0. But yeah, this is another graph that I'm showing here. So the graph actually never touches this line, but yeah, it gets close to it though. So let's say I call this, okay, let's say this is x equals 4. Now, we learned one-sided limits last video. Limit of, we'll call this g of x. Limit of g of x as x approaches 4 from the right side. You look from the right, it's going to go to negative infinity. Now, if you do the opposite and do limit as x approaches 4 from the left side, that was right side. This is now I'm going to go with left side. You're going to get positive infinity. And now if I take it a step further, for the overall limit of g of x as x approaches 4, it's actually going to be, it does not exist because the limits don't match. If they were both infinity, we could say that, like the previous example. However, one is infinity and one is negative infinity. So we cannot say that the limit exists. Let's do one more example. Down here, I'll write one. Limit of x approaches 1 from the left of x squared minus 3x over x minus 1. And then we'll do the right limit as well. Okay? So the graph, I've already graphed this on my graphing calculator. It will look something like that. Okay? And for this, you just take a look at the graph again. And we'll call this point, this is point 1, okay? From the left side, this is going to equal infinity. And from this exact same thing, let me write it real quick. Minus 3x over x minus 1. As x approaches 1 from the right, that's going to be negative infinity. And then let's do the property for infinite limits, because there's actually some properties for infinite limits. Here, let me erase this real quick from the previous video. For infinite limit properties, we have a couple. So it's kind of what you would expect, right? Let's say we have limit of f of x, or actually, let's just call this f. Limit of f. Make this easier. X approaches c, okay? And let's say this equals infinity. Yeah, that's fair. And then let's do limit of L, or not L. Let's do limit of G as x approaches c, and you get L, okay? L being any just real number, okay? Now, if you have something like f, or sorry, same thing, limit of x, so limit of f, or sorry, limit as x approaches c, but it's f plus g or minus g. what do you think it's going to be? Infinity. Because if you break it, it's just going to be infinity plus a number, infinity minus a number. That's still infinity, right? We're not doing anything like infinity minus some other infinity. Just infinity plus or minus some other real number, right? Now, let me do limit of, g over f as x approaches c. Now, g we'll say is, well, g is L, right, that number, and then f is infinity. Well, it's a fraction, right? It's a small number over a big number, but it's a very small number over like a very big number, infinity, right? So it's going to be going towards 0, right? So we can say that this limit will be 0, right? And let me do one more. Limit of x approaches c of, let's do f times g, okay? Now, this actually has two options. What if this L was negative? If L is negative, let me scroll down here. Then, so I'll say if L is less than 0, then I have an option where L is greater than 0. So let's rewrite this. So if L is less than 0, L is negative. It's negative times infinity. It's going to be negative infinity. Whereas if L is positive, then you have a positive number times infinity. You're going to get infinity. So let's just do one last example for this. Let's do two limits. I'll give you two limits. So limit of 1 as x approaches 0. Well, obviously that's 1. Think of the graph y equals 1. It's going to be 1 for every value, even at 0. And then let's say we have limit of x approaches 0 for 1 over x squared equals infinity. And I ask you, well, what is the limit of x approaches 0 of 1 plus 1 over x squared? Now you just do, well, 1 over 0 is here, right? Because think about it this way. You just plug in, right? 1 plus 1 over 0, right? Which is what they did here. 1 over 0 is going to be infinity. Okay, it goes to infinity, right? If you know the graph of 1 over x squared, right? So this goes to 1. You can split the limit, right? This goes to 1. This goes to infinity. You would have 1 plus infinity, which you know from the property is just going to be infinity. So that was just it for this video. If you have any questions, leave it in the comment. Please like and subscribe. And I'll see you for the next video. Thank you.